Alright everybody, so sorry I can't be with you today. What I want to do is have you watch this video and try to teach you the limiting reactant stuff. It is barely a little bit more than what we've been doing for the stoichiometry. So if you're understanding the stoichiometry, great. This should not be a huge jump to catch on to the limiting reactant stuff. For those of you who may be feeling a little unsure about the stoichiometry, this will offer yet another example of how to do the stoichiometry problem, so hopefully it'll help you guys out too a little bit. So as you can see on my directions here, make sure you find the limiting reactant worksheet in your packet. It just says limiting reactant up at the top. It has some notes on it and an example problem that we're going to work through. And then once you find that sheet, just hang out a second. I'm going to go over the notes in the top. We're going to do the example problem together, and I'll have you fill that in. You can fill it in as you're watching and listening to this. And then when we're finished, I'm going to have you work on the last worksheet in your packet, which is the limiting reactant practice problems. And there are several of those that you can work on. I am going to take a look at all of this tomorrow to make sure that you're practicing. Remember, tomorrow will be your review day, and then on Thursday you'll have the test on all of this. So let's move on and talk a little bit about limiting reactants. So hopefully you've got your limiting reactant worksheet. Before we write anything on there, I want to go over the idea of a limiting reactant, because you actually already understand this. And I used the example the other day of a cheeseburger, and I forget what I said we were going to make a cheeseburger out. So I drew you a lovely picture here. So you can see here I have my list of my list of things that make a cheeseburger right here. And so I need all 5 of these things to make a cheeseburger. And so my question is, how many cheeseburgers can I make if I have the following ingredients? I have 8 buns, I have 10 lettuce leaves, I have 8 tomato slices, I have 24 cheese slices, and I have 5 beef patties. So if I need 1 of each, as it's listed up here, so you can see I need 1 of each of these things, looking at what I have, how many cheeseburgers can I make? Well, you should notice that I can actually only make 5 cheeseburgers. And the reason I can only make 5 is because the number of beef patties, notice what's up here, right? My number of beef patties is only 5. And so that limits how many I can make, because once I make my 5 cheeseburgers, my beef patties are gone and I can't make any more cheeseburgers. So what does making cheeseburgers have to do with chemistry? Well, reactions work the same way. In chemistry, the limiting reactant is the thing that runs out first. And when it runs out, it ends the chemical reaction. And so it limits, okay, this idea of limiting here, it limits how much product can be made. And the other reactant, so if it's not the limiting reactant, the other reactant or reactants would be considered in excess. And they're in excess because there is some left over. You have an excess amount of that. So the question then becomes, okay, great, we have this idea of, we have two reactants that go together, one of them runs out and the reaction stops. So mathematically, how do we figure that out? And that's where our example comes in. And so if you read the example with me, I have it printed here on my page, but if you take a look at your practice sheet, nitrogen gas and hydrogen gas react to form ammonia. And if 60.3 grams of nitrogen gas reacts with 11.5 grams of hydrogen, determine which reactant is limiting and calculate the grams of product that will be created. So anytime you are starting any kind of stoichiometry problem, including our limiting reactant problems, we're going to start by writing a balanced chemical equation. So we have nitrogen gas, which is a Brinkelhoff, so I have N2. Hydrogen gas, which is also a Brinkelhoff, so H2, produces ammonia, which is NH3. And then I can go back and balance this. A 2 here and a 3 here gets me balanced. And so I now can look at this and say, okay, this problem is similar to what we've been doing because it's giving me information about my reactants and asking about how much products. But you'll notice this time, instead of just giving me information about 1 reactant, I have information about 2 reactants. It tells me I have 60.3 grams of nitrogen and it's reacting with 11.5 grams of hydrogen. And I need to know which one is limiting, and I need to know the grams of product. So when we're doing this problem, what we're going to do is pick one of these to start with. So this is down to step 2 now. I'm going to just pick one of these to start with, and I'm going to figure out how much product would be produced if I used all of that. So I'm going to start with my 60.3 grams of nitrogen. And I'm going to figure out, using a stoichiometry problem, how much ammonia would be produced if I used up all 60.3 grams. So I set up my problem. Remember, it's N2, so I have 28.02 grams of N2 per mole. So I start by changing to moles, right? And then my next one, I'm going to do moles of N2, because what I started with goes on the bottom. Moles of NH3 up on the top, because that's what I'm looking for, right? Because I'm looking for the grams of product. So for every 1 mole of N2, I make 2 moles of NH3. Where did that come from? That came right from here, from my coefficients in the problem. For every 1 mole of nitrogen, right, because this is a 1 understood here, for every 1 mole of nitrogen, I make 2 moles of ammonia. And then the last step, I'm going to do my 1 mole of ammonia, and I'm going to figure out how many grams that is. 17.04 grams of ammonia, NH3. And so when I do my math, what I find is that I make 73.3 grams of ammonia. Remember, my 17.4 and my 28.02, those are my molar masses from the periodic table. To change mass to moles, I use my mole fraction. This is exactly the same thing that we've been doing as far as my stoichiometry problems. But remember, I'm assuming that if I use all of my 60.3 grams, I'm going to make 73.3 grams of ammonia. But I don't know that for sure, so I have to compare it to the other reactant they give me information. So I'm going to do another problem. This time, I'm going to start with my 11.5 grams of hydrogen. And I'm going to figure out how much ammonia would be made if I use all of the other reactant. So assuming I use all of my hydrogen, I set up a problem just like the last one. 2.02 grams of hydrogen for every 1 mole of hydrogen. I set up my mole fraction, moles of hydrogen to moles of ammonia, NH3. And my mole ratio this time is 2 moles of ammonia for every 3 moles of hydrogen. Again, these come right out of the periodic table, right? 3 to 2 this time. And then the last step, I'm going to change my moles back to grams. For every 1 mole of NH3, I again have 17.04 grams of NH3. And when I do my math, this time I get 64.7 grams of NH3. So that tells me if I use up all of my 11.5 grams of hydrogen, then I'm going to make 64.7 grams of ammonia. So which one is my limiting reactant? That becomes my next question. I've got to compare my 2 values. So if I use up all my nitrogen, I get this much, 73.3. If I use up all of my hydrogen, I get this much, 64.7. And so I know that this is how much is actually going to be made. This 64.7. How do I know this? Because once I get to 64.7 grams of ammonia, my hydrogen is all used up. My hydrogen is going to limit, this is my limiting reactant. My hydrogen is going to limit how much I can make, because once I hit 64.7 grams, it runs out and the reaction stops. I'll never get to 73.3 grams. I'm never going to actually make that much because I won't get past the 64.7. I have no more hydrogen. That means that my hydrogen is my limiting reactant. That also tells me that there will be excess nitrogen in my reaction, because there'll be some of that left over. And I'm going to make my 64.7 grams. What this is called is a theoretical yield. A theoretical yield means if everything goes perfectly, that's how much I can expect to make. This theoretical yield that I get is how much, if I use up my 11.5 grams of hydrogen and react it with excess nitrogen, I'm going to get 64.7 grams of ammonia. So what do you think? Like I said, not too terribly difficult. If you understand how to do the stoichiometry part of this and understand how to do the stoichiometry problems, then literally you do 2 stoichiometry problems and compare your answers at the end. Whichever one makes the least amount of product, that's going to be your theoretical yield, that amount that's made, and the reactant that makes that amount is your limiting reactant. The reactant that makes too much is your excess reactant. So let's flip over the page. There's one more practice one. Let's do one more together, and then you can practice. There's 4 more on the last worksheet that you can work on together. The substitute does have the key for these, so you can check as you're going along. But let's do this last one together. So I have B2O3 plus HF yields BF3 plus H2O, which is the reaction that you're given. It tells me, if you look at the problem with me quick, 10 grams of the B2O3 reacts with 18.5 grams of HF. Since I know 2 amounts, that means I've got to do a limiting reactant problem. I want to know how much BF3 is going to be created and which is the limiting reactant. So like any problem, first thing I'm going to do is do a little bit of balancing to make sure that I have everything balanced and I can use those coefficients for my mole ratios. So looking at this quick, I notice I have 3 oxygens on my reactant side. I'm going to put a 3 over here on my product side so that I have 3 oxygens. That now gives me 6 hydrogens. And so I'm going to make this a 6 here to make my 6 hydrogens, and I have 6 fluorines, and so a 2 here will give me 6 fluorines. That fixes my boron, and I think we're in good shape. So we've got everything balanced. So the next step is to start and do my equations here and do my stoichiometry problems. So I'm going to start with my 10 grams of the B2O3. And I'm going to set up my problem, and I'm going to figure out how much BF3 is made. Now notice I have 2 products this time, but the problem is specifically asking me how much of the BF3, so that's the one I'm going to work with. I'm going to sort of ignore the water. It's not going to take part in this problem at all. It's there in the balanced equation, but I don't care how much is made. Problem is asking me about BF3. Could have just as easily asked me about the water, but it didn't. I'm going to just use the one that the problem asks me about. So first thing I'm going to do is change my grams of B2O3 to moles of B2O3. If I calculate up my molar mass, I have 2 times the mass of boron plus 3 times the mass of oxygen, and so I get 69.62 for my molar mass of the diboron trioxide. So I've got that number in there, so I'm at moles of that. So next step is going to be my mole ratio. So moles of the B2O3 to the moles of BF3, because that's what I'm looking for. Always moles of what you start with on the bottom, moles of what you're looking for on top. And my mole ratio this time is going to be, for every 1 mole of B2O3, I have 2 moles of BF3. And then the last step, I'm going to do one more conversion, and I'm going to change my moles of BF3 to grams of BF3. And how many do I get? I get 67.81. I didn't quite leave myself a whole lot of room there. So I have 67.81 grams. So again, I multiply by everything in the numerator. I divide by everything in the denominator. And what I should find is that I have 19.5 grams of BF3 created. Now again, this tells me if I use up all of my 10 grams, this is how much I'm going to create, 19.5 grams of BF3. But I don't know if I'm going to use it all up. I don't know if I have enough of the other reactant. So that's what I'm going to test with my next problem. I'm going to start with my 18.5 grams of HF, and I'm going to do the same problem, figure out how much BF3 gets made if I use up all of my HF. And so I have 20.01 grams, right? 1.01 plus the 19 grams for the fluorine. And so I have 1 mole of HF. So I've changed grams to moles. Next step, I'm going to change moles of what I started with. So my moles of HF on the bottom. Moles of what I'm looking for. BF3 goes on top. For every 6 moles of HF, I make 2 moles of BF3. And then the last one, for every 1 mole of BF3, I get 67.81 grams of BF3. And if I do my math, again, multiply across the top, divide across the bottom, I get 20.9 grams of BF3. And so again, what does that tell me? It tells me that if I start with 18.5 grams of HF and use up all of that hydrofluoric acid, I get 20.9 grams of BF3. So the question then becomes, how much do I actually get? I actually get this much, right? My 19.5 grams. I'm never going to get to the 20.9 because my 19.5 grams, when I get there, all of my B2O3 is gone. It's been used up. And so my limiting reactant is my B2O3. My excess reactant is my HF. And my theoretical yield, how much I can expect to make, is that 19.5 grams. So when you're doing these problems, what I'm going to be looking for, just to give you an idea, this is probably like a 8 or 9 point problem. Okay, you'll get a point or two for the equation depending on how much I expect you to do there. You'll get a point for each of the parentheses in each of the problems. You'll get a point for telling me which one you're actually going to make. You'll get a point for identifying what's limiting and what's in excess. And so this whole thing is probably about a 9 point problem. So if you can do as much of this as you can do, that's great. And just remember, in terms of partial credit, even if you can't get that equation to work out right, or you screw up something in the equation, if you use the equation correctly and plug it in appropriately underneath, I'm not going to take more points off. So again, don't leave things blank. Work as much through the problem as you can so that you can get some partial credit. So now that we've done a couple of examples, you can work on the last worksheet in your packet. It is a practice sheet of just limiting reactant problems. And like I said, the sub has the answer key so that you can take a look at that and check with him or her as you're going along to make sure that you're doing them correctly. If you've got questions, you can either send me a question on Schoology. I don't know how much I'll be on there looking at things today, but I might be. So you can try sending me a question on Schoology, or you can just hang on to it and we can talk about it tomorrow in class. Good luck!